Hello everyone! Is any of you scared of flying? When the plane takes off and you feel all the vibrations around you? Well, imagine that if those vibrations exceed a certain amount, you might be in this situation. You can see the aero engines of the plane taking fire. Well, this might occur if turbine blades in the engine, undergo excessive vibrations. For this reason, it's very important for us to reduce the amount of vibration. And one of the ways we can reduce vibrations is by means of frictional contacts. We have friction contacts in the connection between the blade and the disc, so that when the blade vibrates, there is a relative sliding between the blade and the disc. What I do in my PhD is actually understand how those frictional contacts reduce the amount of vibration. In order to understand this, I will show you a quick example. This is a bell, and if I shake it, it will produce a sound. Now, if we want to plot this sound that we call dynamic response, we would have a plot like this one, in which we are plotting the amount of vibration versus the number of oscillations per second. In the case of this bell, the bell is vibrating at 300 Hz. Now, if the blade has a crack like this one, when it vibrates, the two interfaces here in contact in the crack will have friction due to relative sliding. And if we plot the sound produced by this broken bell, we would have something like this. In fact, the bell will not produce a sound. And in the case of aero engines, we see that this case is our desirable case because it has a low amount of vibration, which is not dangerous for the safety of the blade, while this case is to be avoided. So what I do in my PhD, I try to understand how friction affects those two different cases, and I also try to model with numerical simulations the same behavior so that we can optimize the design of aero engines. So in next flight, if you are going to feel bad, you have headache, stomachache, or something like that, well, don't worry, because I'm working for you. Thank you very much.